What if your AI could not only fetch the right facts, but truly understand the relationships between them? What if AI could not only answer your questions, but reason through complex knowledge like a human detective connecting clues on a crime board? Hey everyone, welcome back to the channel where we decode the most exciting tech breakthroughs. Meet the next evolution, Graph-Enhanced RAG. Stay tuned to discover how this breakthrough is reshaping AI's ability to reason and generate like never before. Traditional Retrieval-Augmented Generation models are great at pulling knowledge from massive databases like Wikipedia and generating coherent responses. But they struggle when faced with highly interconnected information. This is where graph neural networks come in. We can get an overview of the architecture of graph neural networks from the research paper. In the new graph-based RAG, every piece of knowledge is treated like a node, and the connections between them help the AI reason through relationships. For example, if your query involves historical events and their causes, the model doesn't just pull random facts, but identifies the sequence and impact between them. Think of this as upgrading your librarian into a super intelligent researcher who cross-references everything while answering your question. Remember that RAG systems treat retrieved documents as isolated pieces of information? Graph neural networks enhance RAG by enabling it to model and reason over complex relationships, improving retrieval accuracy, dynamic context awareness, and structured knowledge integration. Therefore, by leveraging GNNs, RAG systems produce more coherent, contextually relevant outputs and excel in tasks requiring multi-hop reasoning or analysis of hierarchical data. But what about topic categorization for different tasks? No worries. Graph neural networks enhance RAG by representing entities and their relationships in a structured way. For example, in a knowledge graph, GNNs can capture relationships between topics, such as prerequisite concepts in education or drug interactions in healthcare. Therefore, it could provide a more contextually relevant and accurate retrieval results. However, further questions come along the way. What about some tasks that belong to multiple groups? This is also resolved by integrating GNNs. RAG can reason across multiple retrieved documents or knowledge fragments by aggregating information from interconnected nodes. Therefore, this aggregation enables the model to synthesize data from disparate sources, offering more coherent and logical responses, especially in tasks requiring multi-hop reasoning or resolving ambiguities between conflicting data points. But here comes another crucial issue. RAG systems often retrieve irrelevant or redundant documents. With traditional methods, it seems impossible to solve. However, GNNs allow RAG to integrate structured data, such as knowledge graphs, into its retrieval and generation processes. Therefore, the model could use not just textual information, but also structured representations of knowledge, enhancing its ability to handle hierarchical or relational data, such as organizational structures, product hierarchies, or legal frameworks. However, even with the relevant data, integrating retrieved content seamlessly into generation remains to be a critical issue for traditional RAG. But the structured representations provided by GNNs guide the generation module to produce outputs that maintain logical consistency and coherence. By reasoning over graph-based relationships, the generator can better align its outputs with the interconnected nature of the retrieved data. Therefore, it reduces inconsistencies and contradictions in responses. But the benefits are far more than solving current issues. GNNs could help RAG on high-quality retrieval mechanisms and enhance the model robustness. GNNs enable dynamic retrieval by prioritizing nodes and edges based on the context of the query. For example, in a graph representing scientific research, the system can prioritize recent, highly cited papers or specific methodologies related to the query. Therefore, it ensures a more precise and relevant information retrieval, tailored to the task at hand. But is this method really working compared to older methods? According to the latest research, the Graph RAG model significantly outperforms traditional models in key areas: quality of generated responses, knowledge consistency, and reasoning capabilities. Here's the proof. Graph RAG scored a massive 0.90 in response quality compared to 0.74 for older models. Therefore, it's a leap forward in how AI thinks and communicates. But Graph RAG systems face several issues and limitations as well. The computational overhead of processing complex graph structures is a huge issue. which can lead to latency and scalability challenges. Encoding large-scale graphs with numerous nodes and edges requires significant memory and computational resources, making real-time applications difficult. The quality of output heavily depends on the completeness and accuracy of the underlying graph data. Missing or incorrect connections can propagate errors throughout the retrieval and generation processes. Even worse, integrating graph-based reasoning with generative models requires careful alignment of graph embeddings and textual data. Finally, the complexity of these systems can reduce interpretability, making it harder to debug or explain decisions, especially when dealing with multi-hop reasoning across dense graphs. Therefore, even though it solves most issues for traditional RAG models, it brings out other issues that are left to be solved. Admittedly, Graph RAG is redefining how we think about AI. In the next video, we will explore another innovative direction to overcome the issues of traditional RAG and unlock more potential of advanced LLMs. Trust me, you won't want to miss it. But what do you think? How could this technology transform your industry? Drop your thoughts in the comments below, and don't forget to like this video and subscribe for more deep dives into the future of AI.